Okay, Year 12. Glad you could join me. Here are questions 5 and 6, as we were talking about today. And here you can see in question 5 that this curve does this and that. It's a graph that does this and this in these two quadrants, this down here and this down here. Now, you should recognize this sort of format as being the graph of a hyperbola. Now, the first hyperbola you will ever see will be one that comes down like that in this quadrant, this quarter of the graph, and goes like that in this quarter of the graph. And that would be what we would call a positive hyperbola, okay? But now, because it's been reflected, this has been reflected over there, and this one is reflected over here. This is a negative hyperbola, okay? Now, this dotted line that I've drawn there, this dotted curve, and this dotted curve there, they could represent the standard curve of a negative hyperbola like that. Y equals minus 1 over x. So here the k value is minus 1. And our curve, which is out here and there, it's as though this curve here, this dotted one, has been moved out that way. Is being moved out that way to there. So clearly our curve does not have the k value of minus 1. The other thing to keep in mind is that because it looks quite clearly that the standard hyperbola there is gone that way and gone that way, there has been no vertical movement of the hyperbola, and there's been no horizontal movement of the hyperbola. Okay, so it's going to be very closely looking like this. Okay, so we can immediately write the equation in this way here, that y equals k over x. Now, as I said before, because we know it's a negative hyperbola, we do not write here y equals minus k over x, because when we put in some numbers that lie on this curve, which I've done here, this 2 minus 1, we will generate a negative value for k. And if we put in a negative value here, we're going to get a conflict, and it's going to come out positive. And you'll be going, oh my gosh, why does it come out positive? Okay, so just put k there, and then use a point that sits on the curve, which 2 minus 1 does. Put them in, and you will find that k comes out as negative. It generates a negative value, which is what you expect. Okay, and in this case, y is minus 1, x is 2, cross multiply the 2, so k is minus 2. So there you can see it, that the complete equation is y equals minus 2 over x. Now, that's all very easy, but for full marks, you want to make sure that you've listed the features. Well, you've given it its name, a negative hyperbola. There are no x or y intercepts, okay? Because if you look at it again, there's no way in which this curve does not cross any axis, and neither does this curve here cross any of those axes. However, if you went all the way to infinity that way and all the way to infinity that way, this x-axis would be an asymptote this way and that way for this top curve here. But the y-axis is also an asymptote if we went that way with the curve and that way with this bottom part of the curve here. Okay, so they are features that you must mention, that the x-axis is an asymptote and the y-axis is an asymptote. Now, we have to be very careful when we talk about the domain and range, because let's look at it here. The domain is all the x values along the x-axis, but there's one value of x that is not allowed, and that is this one here, okay? And that is anywhere along the y-axis is where x is equal to 0, because if this curve here is an asymptote, it approaches the y-axis at infinity, but it never touches. And if it never touches, then x cannot take the value 0. And the same is true for this x asymptote here. And here what we say is that the value of y, this is the range of is that it's all the values of y except the value 0, because as you go that way with the curve, as you go that way with the curve, it gets closer and closer to the x-axis, but never touches. If it never touches, then y cannot take the value 0. So when you talk about the domain and range, you would say something like this: all values of x, but in brackets, the x cannot equal 0. You might want to write it like this, that x has to be less than 0 and x has to be greater than 0, but x can't equal 0. The same is true of the range, all values of y, but y cannot equal 0, or y is less than 0, all the negative values of y, and y is greater than 0, all the positive values of y, but not y is equal to 0. Okay, let's look at this next example, question 6. And unfortunately, the lighting wasn't so good and it's a little bit glary, but I hope you can still read it. Okay, well, let's look at this one first. First of all, the hyperbola, that's what it is. It's a positive hyperbola, by the way, because you've got this curve coming from this quadrant, and you've got this curve here in this quadrant, okay? So you would describe it as a positive hyperbole. However, its equation needs to be carefully looked at. How do we do this? Well, one quite obvious thing that you need to look at first of all is where are the asymptotes. And if you look carefully, you will see that there must be an asymptote here, this vertical asymptote at x equals 1, and there must be a horizontal asymptote there where y is equal to 3. Now if you can imagine, you see these axes here, this is the y-axis and this is the x-axis. Imagine I could pick it up at the origin and move it to there. Then the asymptotes really look like where the axes would be. If I move that origin, if I moved it up to there while the curve stayed where it was, the curve doesn't move. So, but imagine the curve doesn't move, but just the axis. So the axis would move like that up to there. Well, in other words, your axes have moved 1 unit that way in the positive x direction and 3 units up in the positive y direction. Now, if that is the case, we know now that the equation changes, because the bottom part of the equation, where the x normally is, now has to have -1 in brackets written to it, like it, because it's gone 1 in the positive direction, so we write negative there. And there's a +3 at the end because it's been moved up 3, like that. So that's how we build that equation. Of course, we don't know k's value. So we look for a point on the curve, and I've chosen this one here, which is on your curve. It's at 2, 4. And we put that in to the equation that we're building up to find k's value. Now this is where where it gets a little bit difficult to see because of the glare. But I think you can see that I've put 4 for y, and I've put 2 here for the x. Now we just work this out for k. So I'm taking this plus 3 across. There it is, minus 3. So it's 4 minus 3, which is 1. And this 2 minus 1 goes to 1. So 1 is equal to k over 1. So that must mean that k is itself equal to 1. So there is the equation, the complete equation. Y equals 1 over x minus 1 in brackets, and then plus 3 at the end. Now the features are the following. It's a positive hyperbola. That's its name. It has an asymptote at y equals 3. It has another asymptote at x equals 1. Now there is a y-intercept at 0, 2. Well, what am I talking about? I'm talking about where it crosses the y-axis, which is there. Okay, coordinates. So you're talking about an intercept here of 0, 2. Now look here. There's an intercept on the x-axis. Now I'm challenging you to find what the value is on the x-axis. Okay, now I've written it there. It's 2/3. It means that when it crosses the x-axis, y's value is 0, which means that in your equation you will set y to 0 and you'll solve the equation for x. Well, what I would do, and I'm challenging you to try this for yourself, take the plus 3 over there, and that becomes now minus 3. You got minus 3 is 1 over x minus 1. You could then cross multiply the minus 3 down here and the x minus 1 up there, and I'll let you do the rest to find out why it works out as 2/3. If you do that properly, you will see that in fact the x equals 2/3, and that, if you look at the graph, you'll see that that's roughly correct. If that's a half there, then that's roughly 2/3 about there. Okay, so that's the features mentioned. Now we then need to talk about the values of x for the domain. Again, I've written here that x does not equal 1. Okay, and the range here that the y is all the values of y, but y cannot equal 3. That is because those two values for x and y, look what you've got. You've got along this value of x equals 1, you've got no graph. The graph cannot touch the asymptote there or there. And the same is true here. Anywhere along y equals 3, the graph cannot touch. And the same in that direction, and it's the same in this direction here. So you can quote all the values of y, for the range, except where y is equal to 3. And you can quote all the values of x for this graph, except where x equals 1. Okay, now that if you did all of that, mentioning the features and the domain and the range of your graph, you will get excellence. Okay, as well as finding the equation of the graph correctly. Okay, guys. Now I hope that's helped. And I'm going to be setting you some homework. I probably did already in the lesson. I'm making this video the day before your lesson, so we'll have the lesson and then I'll let you watch the video to back up what we do in the lesson. Okay, thank you very much for listening. Goodbye.